This is activity on node for a critical path method. I will show you manual calculations. In each node, there are two numbers. The top number is the activity name, but I will highlight the bottom number so we know to use them in our calculations and we don't get them confused with the activity names. So for each activity, I will generate 4 time estimates. Earliest start and earliest finish times go at the top. Latest start and latest finish times go at the bottom. The ones on the top are called, we can interpret them with the verb can. So the earliest time that an activity can be started and finished, and the ones in the bottom with the verb must, the earliest and latest time that an activity must be finished. Must be started and finished. Activity 1 is starting activity for the project. So at the earliest, it can start in time period 0. It takes 3 months. We perform a summation. 0 plus 3 is 3. Activity 2 can only begin after 1 is finished. 1 will be finished at the earliest in time period 3. So at the earliest, activity 2 can start in time period 3. 3 plus 2 is 5. By the same logic, I can use 3 for activity 3's earliest start time. Plus 1, we get 4. For activity 4, both 2 and 3 are prerequisites or predecessors. So it cannot start until both of those have been finished. Well, look, activity 2 at the earliest can finish in time period 5. And this one can, at the earliest, activity 3, can can finish at the earliest in time period 4. So activity 4 must wait for both of them to be finished. So at the earliest, it can start at time period 5. So in our forward pass, the rule we just learned is that we pick the highest early finish time of predecessor activities for an activity that has multiple predecessors. 5 plus 3 is 8. For activity 5, the same logic applies, but now 5 plus 1 is 6. Activity 6, earliest start time is 6, which we take this 6 from over here and we use it. Plus 1 is 7. And then for activity 7, again, the forward pass rule applies. We pick 8. 8 plus 1 is 9. So this project can be finished in as early as, remember earliest finish time? This project can be finished in as early as 9 weeks if we do everything right and everything is aligned for completion in the same manner that the time estimates have told us. So I'm going to take these off now. Okay, and now for our backward pass, we will put activity, we will put 9 as our latest finish time, which is this 9 right here. So essentially we're saying that this activity can be finished in 9 months, but we want that it must be finished in 9 months. So now in our backward pass, we perform a subtraction. 9 minus 1 is 8. This is the latest time that activity 7 must be started in month 8, so that when it takes 1 month to be finished, at the latest it can be finished in month 9. Okay, so this 8, which is the latest start for activity 7, I will use that for activity 6, and that's the latest finish time. So that activity 6 can, with this 8, which is its latest finish time, can support and accommodate activity 7. So this 8 minus 1 is 7. 7 I'll write it over here, minus 1, we get 6. Now look, for activity 3, there are 2 successor activities, 4 and 5. Because activity 3 must accommodate both of them, at the latest, it must be finished in such a way so that activity 4 and 5 are not delayed. Maybe I should write this first here. For activity 4, we have 8 minus 3 is 5. So the choice is between 5 and 6. And I picked the lower number because, as I said, activity 3 must accommodate both of them. So 5 minus 1 is 4. Then the same logic applies here. For activity 2, both 4 and 5 are successor activities. So 2 must accommodate both of them. So I will pick the lower number, 5. 5 minus 2 is 3. So let me summarize it here. In the backward pass, we pick the lowest value of latest start times when an activity has more than one successor activity. We pick the lowest of the latest start times of those activities to set as the latest finish time for the activity that we're interested in computing its numbers. Okay, and finally, for activity 1, the choice is between 3 and 4. I pick the lower number and I get 0. So at this point, let me go ahead and talk about slack, which is also called float or sometimes buffer. And this is the time that an activity can be delayed without delaying the project beyond its expected or computed finish time. There are two ways to compute slack. One is to subtract LF and EF from each other. So LF minus EF is buffer or slack. And another way is to subtract LS and ES from each other. So latest start minus earliest start. So with these two ways, applying both of those, let's compute slack for these activities. 3 minus 3 is 0. 0 minus 0 is 0. For this one, it's 0. For this one, 0. For this one, 5 minus 4 is 1. And 4 minus 3 is 1. This is 1, this is 1, and this one is 0. The critical path is comprised of all those activities that have a slack of 0. And that means that if we slip up or we mess up in any of those activities, then the project will be delayed beyond its 9-month completion time. Now, let's look at all the paths that are in this project. One is the critical path that we have identified. 1, 2, 4, 7. Those are the activities on it. And if you add them up, you get 3 plus 2 is 5, plus 3 is 8, plus 1 is 9. So that's how we got our critical path. Another path is 1, 2, 5, 6, 7. 1, 2, 5, 6, 7. Let's see what the duration for that is. I'm going to add up all the times on that path. 3 plus 2 is 5, 6, 7, 8. Another path is 1, 3, 4, 7. 1, 3, 4, 7. And the duration for that is 3 plus 1 is 4, 7, 8. And finally, we have one more path, and it's 1, 3, 5, 6, 7. 1, 3, 5, 6, 7. And that duration is 3, 4, 5, 6, 7. So as you can see that of all the paths in the network, the critical path is the longest path through the network. And that's by definition true. The critical path is the longest path through the network. But counterintuitively, it is also the earliest time that you can finish this project. You cannot finish this project any earlier than 9 months if these resources are allocated to it. There is such a thing as crashing that will be the subject of a future video, but for now we need to know that the critical path is the longest path through the network. The next video will be on very short and on the subject of shared Slack amongst activities, and then we'll talk about PERT, Program Evaluation Review Technique, and how to compute probability estimates of project completion time. Thank you.